Hey, welcome. Hey, welcome back. This is Math 0955, and today we want to work with graphing linear equations by using their x and y intercepts. So problem 1 here, we begin just by visually identifying intercepts. So let me try to reproduce the picture here. Looks like there's a intersect on the y-axis at 3, and then there's an intersect on the x-axis at 5. Okay, so 1, 2, 3, 4, 5, and then the line is going through like this. Some arrowheads on there. So quite literally, the x-intersect is the place where the line hits the x-axis. Okay, so again, this is the x-axis, this is the y-axis. So the x-intercept is going to be that point. In some classes, they'll have you write the location or the ordered pairs. I believe here they just want you to write the x value associated with that intercept. So the x-intercept they're going to say is 5, right? So, but as a location, you would write 5, 0, and I wrote my 5 upside down for some reason. Let me erase that. Try again. Give you a second try. There you go. All right. So, but you're not going to put 5, 0, right? You're just going to write 5 for the x-intercept, and there you go. Then the y-intercept is the place where the line hits the y-axis, so that'd be right there. So its location, again, there's this issue, what's the location, what's the actual y-intercept? The location is going to be at 0, 3, but the answer they want is 3 for the intercept. Okay. On my test, you can put either, you can just write 5, or you can put the ordered pair. Let's see. The same kind of problem, you're just locating positions where the line hits the x and y. This one's a little weird, so problem 3, because there only seems to be one intercept, right? The line is going straight through the origin, but it turns out that both x and the y-intercept are going to be 0. The location of the x-intercept is at 0, 0, and then you'll say the x-intercept is that x-coordinate of the ordered pair, which is just 0. And then the location of the y-intercept is also 0, 0. Okay. So this is the x-axis, this is y-axis, and the line is going through 0, 0, the origin. All right, so seems a bit odd, but that's what you do. You just put 0 in for both of them and move on. Right? Don't overthink it. So this one's a bit odd because it's a straight line, a horizontal line. And horizontal lines and vertical lines typically only have one intercept, right? If it goes through the origin, it has both intercepts, but if it's something like this, where 1, 2, 3, 4, where it's horizontal and, whoops, I missed the intercept. In that case, it's just going to have one intercept. In this case, it's hitting the y-axis, so there's no x-intercept. It never hits the x-axis. So over here in the homework, you just got to type in there's no x-intercept, great. And then there is a y-intercept though. So the y-intercept is at the location 0, 4, and of course you'll type in the y-coordinate, which is 4. Yay. All right. From there, from the visual kind of identification problems, then you'll get into these ones where you're finding the intercepts algebraically. So question 5, they give us the equation 4x plus 3y equals 12. For the x-intercept, you let y equal 0. Okay, and the equation, you just plop 0 in for y. Okay. So you would end up with 4x equals 12, and therefore x equals 3. Okay, the ordered pair, then x is 3, and you let y equal 0. So the ordered pair, the location is 3, 0. Of course, in the homework, they want you to just type in 3. On my test, I don't care if you do either way. Then the y-intercept, for the y-intercept, you let x equal 0. Okay, so plugging in 0 wherever you see x, and then you solve for y. 4 times 0 is 0. So you just get this, and then divide both sides by 3, and you get y is 4. So the location 0, 4, but again, you need to plot in 4 for your answer. And then it's just rinse and repeat. Looks like there's going to be a bunch of these that you got to do. Let's skip forward a little bit. Maybe this one is odd because both the intercepts will be 0, I think. Let's look at it. So that's always weird, but you know, like I said, don't overthink this stuff. You just want to sometimes operate like a robot to get through. But anyways, so the x-intercept, you let y equal 0, right? So you'd have 3x minus 8 times 0 is 0. 8 times 0 is 0, so you just have 3x is 0, divide by 3, and of course x is 0. So the location is 0, 0, and the actual x-intercept is 0. So this is the case from above where it's just going through the origin. And the same game with the other guy, the y-intercept, you let x equal 0. So you'd have 3 times 0 minus 8y is 0. That will just be minus 8y is 0, divide by minus 8, and you get y is 0. Okay. Location 0, 0, but the intercept, just going to put 0. Right. Okay, so that one was weird. This one's a little different because it's not in that ax plus by equals c kind of form, but the operating procedure is exactly the same. So I guess we might as well look at number 9. We have 3x equals 2y minus 7. So for the x-intercept, you're letting y equal 0. And you'll have 3x equals 0, 2 times 0 if you want, minus 7. So 2 times 0 is just 0. And then 0 minus 7 is minus 7. Then you're going to divide both sides by 3. Yeah, it looks like the x-intercept is a fraction this time, which does happen. So it's negative 7/3, and I broke my pen. There it goes. Oh, nope. Nope. I accidentally hit a button on my pen. I'm going to have to throw it away. That sort of deal. Okay, so there it is. Negative 7/3, 0. Of course, over here you're plugging in negative 7/3. And the other character for the y-intercept, you always let x equal 0. So you're plugging 0 into my equation, which I've lost. There it is. So you get 3 times 0 equals 2y minus 7. 3 times 0 is 0. I want to solve for y. So I'm going to move the 7 over. Divide both sides by 2. I'm going to flip-flop sides. I'm getting 7/2. So the location is 0, 7/2. And then the actual y-intercept is 7/2. Just get some fractions sometimes. That's okay. When you graph those, you know, convert them to decimals. All right, so now in problem 10, we're actually going to start graphing these things using the intercepts. So this one's pretty easy. X plus y is 4. So for the x-intercept, you let y equal 0, and then solve for x. So x plus 0 is 4. So x is 4, and the location then is 4, 0. For the y-intercept, you let x equal 0, right? So I'll have 0 plus y is 4, so y will be 4. And then you can just read off the coordinates, right? The x is 0, y is 4, so it'll be 0, 4. And then you're left with plotting the thing. On my test, you could just draw out some the x and y axes and then plot the points. put some tick marks on there so it looks official. Okay, so there's 4 zeros right here, 0 4s right here, and then you're connecting the dots and putting arrowheads on the line. Okay, so here, click on the graph. You always hit that second button. That's the line tool. And then you're just going to plot those 2 points. So you click on 0 4, click on 4 0, check your answer, and you're good to go. All right, rinse, repeat. So a lot of these kind of problems, they're asking you to also do checkpoints, which I don't really require on my test, but sometimes you're forced to do the checkpoints, right? Anyways, let's try number 13. Negative x plus 4y. And a checkpoint is just doing another point in addition to the x and the y. Okay, I'll show you here in the next problem. All right, so anyways, in this one, the x-intercept, you're letting y equal 0. So you get negative x plus 0 is 6. And then that will just be negative x equals 6. And then you're multiplying both sides by negative 1. So you get x equals negative 6. So the location, negative 6, 0. Then for your y-intercept, you let x equals 0. So you'll have 0 plus 4y, which is just 4y, equals 6. Then you get y is 6 fourths, which is 3 halves. And for graphing, that will be 1.5. So 0, 1.5. And then you go and do your graph. So negative 6, 0 is way over here. 0, 1.5 is in between 1 and 2 on the y-axis. Connect your dots, put arrowheads on them. Okay, so over here in my math lab land, you're going to hit on that second tool. And then you're going to go negative 6, 0 is right about there. And then you're going to hit 0, 1.5 right about there. Check your answer, and you're good to go. Okay, so when they ask for a checkpoint, like I said, you're just doing a third point. And so number 14, you can think of it as kind of just completing a table, right? So for us, we automatically have to do the x-intercept and the y-intercept. So for the x-intercept, you let y be 0. For the x-intercept, you let, for the x-intercept, you let y be 0. For the y-intercept, you let x be 0. And then you just do another point on top of that, right? So again, for the x-intercept, you're letting y be 0. Let me write out the equation. 2x minus y is 1. So you'll have 2x minus 0 is 1. So you have 2x equals 1. And then divide both sides by 2. So x is 1/2, which of course is just 0.5. So your ordered pair here on the left in the table would be 0.5, 0. For the y-intercept, you're letting x equals 0. So you'll have 2 times 0 minus y is 1. 2 times 0 is 0, minus y is just minus y. And then you're multiplying both sides by a negative 1. So you get y is negative 1. So here you'll have negative 1. And then for the checkpoint, I'll just write CP for checkpoint. Here I'm saying let x equal 1. So in the equation, put in 1 for x. So 2 minus y is 1. And then just solve for y. Looks like we got to multiply by a negative 1. This will be y equals 1. So when x is 1, y is 1. And then we get 3 points for our table. It's not really necessary to have those 3 points, but it'll keep you from making mistakes. So if one of the points is out of line, you know you made a mistake. Anyways, I'm going to need to enlarge in this a little bit. And we go to our tool. And I have 0.50 and then 0, negative 1. And then 1, 1 better be on that line, right? So you could kind of find where 1, 1 is, and it looks like it's going to be on the line, so it works. So for the actual graphing part in this homework problem, you don't need that checkpoint, right? You can just do the 2 points and wing it, but the checkpoint allows you to make sure it's correct. It's more of the same, just plug in your answer. Okay, so the cases where you absolutely need the checkpoint are problems like number 18. Okay, so we have x minus 2y is equal to 0. And again, you could kind of think of this as you're filling out a table of values. There's the x-intercept, then the y-intercept, and then just pick a random point on top of it. So usually just let x equal 1, but you can use any point you want. So anyways, the x-intercept, you let y be 0. So you'll have x minus 2 times 0 is 0. Then that's just x equals 0. So 0, 0. And then for the y-intercept, you let x equals 0. Right? So you have 0 minus 2y is 0. So you get minus 2y is 0, divide. So you get y is 0, so 0, 0. And that, I mean, if you try to plot it now, you're just not going to be able to, because you go to the point, you put it on there, and it's not clear, where the second point is. It could be any of these lines. It could be like this, it could be like this, it could be like this, I don't know. So you need that third point in order to basically draw the line. There's no way around it. So I'll try 1, so I'll have x minus, well, I'm putting in 1 for x. And it's probably a good idea to use a value that's not going to result in a fraction. So I'm going to cheat a little and put 2 in there because I know I'm going to have to divide by 2. So in this case, it will be 2, but you could use a fraction and just plot the decimal. So I'll have 2 minus 2y is 0, minus the 2. So you get minus 2y is minus 2. Divide both sides by minus 2. It looks like y is 1. Okay. So going back here, I just have to go the 2 and then 1, and that should do it. Okay, 19 is the same kind of problem. Okay, so this looks like just another intercept problem, but they've given us the graphs, and we just have to pick the appropriate graph. Here, okay, so now we're getting into horizontal and vertical lines. So horizontal lines will look like what we have in that homework problem there. It look like the horizon, right? You look out, if you're sitting on the beach and you look out at the sea, you see a straight line going sideways, right? That's the horizon, and that's a horizontal line. Horizontal lines usually only have one intercept, and the form then will be y equals whatever that intercept is. Okay. Usually we use the letter B for horizontal lines. For vertical lines, then they'll look like this. So like a vertical jump in basketball. In those cases, there's only one intercept, and it's on the x. It's usually just one intercept on the x-axis. So you'll have x equal to whatever that value is. Okay. So for instance, in problem 21 there, we have this picture, 2, 3, 4, 5, 6, 7, 8. Looks like the line is going through there. So the equation is, and if you'd like to, you can kind of set it up like a table and just identify points on the graph. So we have 0, 1, 2, 3, 4, 5, 6, -7. Then we have 1, -7. And then we have 2, -7. It's right there. So you could kind of figure it out in that way by noting that y is always -7. That's going to be your equation. Y is -7. Okay. And when you go to type in your answer here, then you have to use the y equals -7 for your whole answer. Number 22 is just a vertical version of this problem. 2, 3, 4, 5, 6, 7, 8. So it looks like it's going through x equals 6. And that literally is then, if you could locate that position where it's going through the x-axis, that tells you the formula basically. So that's an x equals 6, and that will be your formula. If you want to do that table like I was doing, you can just identify points on the graph. So there's 3 points right there. But the coordinates will always be 6 comma something, right? So it's 6 comma 0, 6 comma 1, 6 comma 2, but it's always x equals 6, and that's your formula then. X equals 6. Okay. This is obviously a weird one in that it has an x and a y intercept, but it's a horizontal line. Let's graph it here. So it's on the x-axis basically. I'll graph it in blue. Hopefully you can see that. And here again, I'm just going to kind of do a little table and note all of the coordinates and see if I can kind of pick out, you know, x equals always something or y equals always something. So go x, y. And so what are the coordinates? There's 0, 0. There's 1, 0. There's 2, 0. Are all coordinates on the line. So it looks like it's going to be y equals 0. And that's it. I mean, a horizontal line is always y equals something. It's going through the origin 0, 0. It's the y coordinate there. And of course, you have to type it as an equation. It's not going to let you get away with that. It sounds a bit weird. Then here you're graphing, so 24, and I think I just broke my pen again because I hit the wrong button. 24, y equals 1. So you could think of it as ordered pairs if you want. Y is always 1, and you could make x whatever the heck you want, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So even if you don't remember that it's a horizontal line, you could just make these ordered pairs, let y always equal 1, and let x be whatever the heck you want, and then just plot all those points. So it would be 0, 1, 1, 1, 2, 1, and then connect the dots, and you see it's a horizontal line going through 1. Shoot, let's go over here, click on that. 1, 1, 2, 0, 1, 2, 1, 1, 1, and then check your answer, and you should be good. Let's try number 26. So x is -2. Okay, so if you want, you can just do this table and say x is always -2. And then y can vary over the real numbers. So you can make y whatever you want. And then you can just plot those points, and you should have a vertical line in this case. Okay, so -2, 0, -2, 1, -2, 2, and there she blows. Okay, so go over to your graph, hit the second tool, -1, or it's -2, 0, -2, 2, and that'll work. Okay, 27, you see x minus 5 equals 0. To get those done, you're going to have to solve for x to get it into our form, right? So it would be x, add 5 to both sides. So x is always 5. So 5, 0, 5, 1. Same deal here. So y will always be -4.5. X equaling 0, that will be the y-axis. Okay, so x equals 0. Again, if you're not sure, you can just do this table where x is always 0 and let y be whatever the heck you want. Okay, so you'll have 0, 0, 0, 2, 0, 3, 0, 1, and the line is just the y-axis. Okay. So 0, 0, 0, 2, and check your answer, yay. Number 30 is another one of these ones where you have to solve for the variable. So you have 2y equals 6. You need to get y all by itself. So you get y is 3, and then your table, you're thinking, let x be whatever the heck you want, but y always has to be 3. So on the graph, 0, and then 3, and then 1, 3. Your answer, yay. 31 is the same game. It's a little more work to get the equation, right? So you have 6 minus 2x is 0. You can add 2x to both sides. Divide by 2. So in this case, it's just a vertical line through x equals 3. And if you don't like that, you can do your table and then graph the thing. So we'll just graph it over here in my math lab. So 1, 2, 3, 0, 1, 2, 3, 1. Check your answer, and you should be good to go. Okay, now we're getting into more of the kind of application type exercises. In this problem, it's a graph of a bird's height over time. So it's going to start out there really high, almost 50 meters. That's the y-intercept. Looks like it's 41, 2, 3, 4, 5, 6, maybe 7. 47 meters high. And then it's flying level, and then it drops down to almost 0, and then around 15 seconds. And then it's going to start increasing from, I guess, 17 seconds to 30 seconds. And that's what they're asking. When is the bird increasing in height? And you just look at that blue line. So over here to the right in my notepad, here's the XY plane. It's up there flying level, and then it swoops down. It's doing something on the ground, probably picking up a worm or something, and then it's popping back up, right? So the interval where it's increasing is that last part. So it was on the ground, and then it's here in blue, it's swooping back up. And you just have to figure out kind of the x values for where that's happening. So if you look at the x-axis on the graph, it looks like it's going 15, 16, 17. Maybe it's starting at 18 seconds. And sometimes you literally have to guess because the graph just isn't all that easy to read. So yeah, definitely 15, 16, 17, 18 seconds. And then it's going up to, and I'll go in reverse, 50, 49, 48, 47. No, 30 seconds. Sorry, just look at the x-axis there. Actually, we don't know what it's doing after 30 seconds, but we'll just say, for the sake of sanity. Got another one. So what is the y-intercept? That's where the time is 0, right? The x-coordinate is 0. So again, on this graph on the left here, the y-intercept is this point right here. That's where it hits the y-axis, right? So you see the x-axis, that's the y-axis. So it's that point is your y-intercept. And what is that point? We're just reading off the graph, 50, 49, 48. Where am I? 50, 49, 48, 47. Looks like 46, 0, 46. Oh, and you just write 46 for the y-intercept. And then, what does this mean? It means that the bird is, when you first see it, it's 46 feet above the ground. or meters in this case. Okay, another application. A new car is worth 36 grand and it's depreciating by 6 grand a year. So the variable amount is the 6,000. It's going down by 6,000, so you're going to make that negative 6,000 x. So x is the year. And then the sort of the fixed amount is what you pay for it, so that'd be $36,000, and that value will equal the value of the car after X years. And they give you that formula, I guess, in the equation. Okay, part A, find the x-intercept and describe what it means in terms of the car value. So again, I want to note what the x and the y are. So x is the number of years after you buy it. And then y is going to be the value of the car in that particular year. Okay, so A, the x-intercept, you let y equals 0. So 0 will be negative 6,000 x plus 36,000. And then I want to solve for x. So I'm just going to add the 6,000 over. So I get 6,000 x equals 36,000. Then I'm going to divide both sides by 6 grand. Then I'll get x equals 6. So it looks like the x-intercept is telling me that 6 years after I purchase, the value of the car will be 0, right? So the ordered pair is 6, 0, and we know the x represents years after purchase. And the y represents the value of the car. Okay, so anyways, the 6 is the x-intercept. What does that mean in terms of car value? It's worth nothing after 6 years. Okay, go on to the y-intercept. So part B, for the y-intercept, you let x equals 0. So in the formula, you get y equals negative 6,000 times 0 plus 36,000. That will equal just 0 plus 36,000, which is 36,000. So the ordered pair is 0, 36,000. And what does that mean? That means 0 years after you buy it, it's worth 36,000, right? Which is basically just how much you bought the car for. So again, this is years after purchase. And this is the value. Okay, so the y-intercept is 36,000. Oops. Was that 360,000? Okay, sorry. I got carried away. Probably a nice car there. So basically, the original value of the car is 36 grand. It's just what I was going on about. Graph it. So use the, it's going to be 0, 36,000. So you look for a graph that, I think maybe this one or this one. But then the x-intercept is at 0, 6, 0, so it has to be A. Part D, the car's value after 4 years. For part D, I just use the formula. Maybe they want you to use the graph, but yeah, in part D, they want you to use the graph. But honestly, reading that little graph is kind of hard. So what I'm going to do is just plop in 4 for x, right? So it'd be negative 6,000 times 4 plus 36,000. So that'd be negative 24,000 plus 36,000, and that'll equal, looks like 12,000. So after 4 years, it's only worth 12 grand. Yay. Okay, I guess that'll do us for today. Thank you for watching as usual, and I will see you next time.